Good morning, students. Welcome to the chemistry class. I hope all are safe, children. For this video, that is, we see the topic actinoid. Actinoids. Okay, children. The previous video, we saw the lanthanoids topic. So, following that is the actinoids. Okay. So, we know very well in the periodic table that is 4, that is a block, it is present. S block, B block, D block and F block, children. So, now we see that is the topic as F block. Okay, so in that is the F block have two series. One is lanthanoid series and another one is actinoid series. The previous video we saw the lanthanoids concept. Okay, children. For this video we are going to see that is the concept about actinoids. Okay, so first we see the definition. Actinoids, the 14 elements following actinium. Okay, the 14 elements, that means that is thorium, TH, atomic number 92, lawrencium, atomic number 103. So this is known as actinoids. In another way, that is, we say the definition, the elements in which the electron enter in, that is 5f orbitals, are called, that is, actinoids. Okay, so now if it is the electron enter in 4f orbital, mean that is lanthanoid series. The electron enter in 5f orbital, it is called as actinoids series. Okay, children. So now that is, see this 14 elements electronic configuration. So next one, study the oxidation state. Next, distinguish lanthanoids, actinoids. This is the concept. Okay, so now these 14 elements are, that is the radioactive elements. Radioactive elements. Normally in S block, that is, we say that is the metal. B block, metals, non-metals. D block, we say that is the metals. Okay, so in that is the F block, that is actinoid, that is elements, that is radioactive elements. In lanthanoid, only that is the promethium, the element alone, radioactive elements. Remaining, that is the non-radioactive elements. Okay, here all the elements are radioactive elements. So now we must know that is the meaning about radioactive. So radioactive means nothing but the substance that is spontaneously that is emitting radioactive rays. So this radioactive rays mean that is alpha ray, beta ray and gamma rays. Okay, so this radioactive, it is related to the nuclear phenomena, nucleus. Okay, that means it is connected with instability of the nucleus. Okay, children. Okay, so now this actinoid, that is short, half, that is lies even in 3 minutes. Okay, so next one, that is talk about some elements, it is obtained in nature, some element that is obtained in synthetic, that is artificially. So uranium and thorium is obtained, that is nature. Okay, so that is neptunium and heavier, that is elements, it is obtained, that is synthetically by the nuclear reactions. Okay, next the plutonium, that is element that is present in, that is the small amount of plutonium, it is present in, that is uranium. Okay, so next we are going to see the electronic configuration. So now see the topic actinoid. So actinoid, that is contained, that is the 14 elements, that is thorium to lawrencium. Here the electron enter in 5f orbital. All the elements are radioactive elements, short half-life. Uranium and thorium, that is obtained in nature. Others, that is synthetically by the nuclear reaction method we obtained. Okay children. So now electronic configuration. Okay, so now I dictate the 14 elements one by one. You recite that is along with me. Okay children, so you can pick up is very easily. So next one, the electronic configuration, how to write, that is I'm going to explain. That is I follow, that is I give some tips how to write in easy manner. Okay, to follow this and study this topic. Okay children, so here that is 14 elements in actinoids, that is the series. So first one, that is thorium. Okay, so next one, protactinium. Next, uranium. Neptunium, plutonium, americium. Okay, americium. Curium. Perchelium. Perchelium. So next, californium. Einsteinium. Fermium. Mendelevium. Nobelium. Lawrencium. Okay children, so see here, thorium, TH symbol, protactinium, that is PA, okay, uranium, U, neptunium, NP, plutonium, that is PU, americium, AM, curium, CM, perchelium, BK, californium, CF, Einsteinium, that is ES, Einsteinium, fermium, FM symbol, mendelevium, MD, mental, okay, MD, nobelium, NO, and lawrencium, that is LR. So this is the 14 elements. Okay children. So this 14 elements, now we are going to write the electronic configuration. So the general electronic configuration, it is the formula radon, RN. This is the noble gas. Okay. So next one, that is 5F. Here 2 to 14. Okay. So next one, 6D, 0, 1, 2. Okay. So next 7S2. So this is the general electronic configuration. So now we are adding electron in, that is the F orbital. So this is, that is F block. This is known as F block elements. Okay. So radon 5F, 2 to 14, 6D, 0, 1 or 2. Okay. Next one, 7S2. Okay. Children, now I am writing this elements, 14 elements. Okay. So once again I recall: thorium, protactinium, uranium, neptunium, plutonium, americium, curium, perchelium, californium, einsteinium, fermium, mendelevium, nobelium, lawrencium, and write the symbol also and write the atomic number 90 to 103, 90, 91, 92. Okay children. So now we are going to write the electronic configuration. Okay, so always you must keep in your mind the general terms. Okay, so the general terms, that is Rn. This one atomic number, that is 86. Okay, 86 atomic number. Write down. Next 5F. Okay, next 6D and 7S. So this always 7S, that is 2. Okay children. So same way for first I trade on 5F, 60 and this 7S. Next I give the trick. Okay, how to, that is to fill 5F as well as 6D. Okay children. So this is the, I use as a rough fork. Okay, here. So now here totally 14 element. So now here write, that is starting from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. Okay children. Here 1, 5 and 8. This number 1, 5 and 8. These three numbers, it is not possible. Okay, that is, it is not possible for, that is 5F orbital. That alone keep in your mind. That means 1, 5 and 8 should not write. Okay children. So now here, so this one for, that is 1, it not writing. So here starting from 0. Okay, so 1 should not write. So 2, 3, 4, 5 should not write. So 6, 7, 7, that is the half filled. Okay, so write 2 times. 8 also it is not writing. So 9, 10, 11, 12, 13, 14 and 14. This 14, 14 2 times, 7, 7 2 times. This one half filled, this one completely filled. Now studying the F orbital. Okay children. So these numbers now we are going to enter in 5F orbital. Okay children. So now see here atomic number 90. So 86. Here that is 5F 0. Okay. So 86, 88. Okay. So remaining 2. That's all. 6D2. So this is the way to write the electronic configuration. Okay. See children. Now that is I'm writing everything. So see here, this one atomic number 91, this one 86. Okay, so we know how to, that is fill the 5F orbital. This is the 5F column. Okay children. So just forgot this column, just leave it. Okay, so now this is the 5F column. So now here 5F, how many? That is 2. Okay, same way for here 3, 4, 6, 7, 7, 9, 10, 11, 12, 13, 14 and 14. At the same time, to fill the 7S column also, 7S 2. Okay, so 2, 2, 2, 2, 2, 2, 2, 2 and 2. Very clear children. Next we are going to fill the 6D. Okay, so here 91, here 86. Okay, so here 2, 2, 4, 90. So remaining 1. So D 61. This is the way to write the electronic configuration. Okay, so here 86. Okay, 89, 91, 92. So here 1. Okay, children. This is the way to write the electronic configuration. Okay, so I hope you can understand this. Okay children, because you can't able to mug up. Okay, so easy way to keep it in mind, that is the 5F. So remaining 7S for everyone, 2, 2, 2. So next to, that is count the radon 5F 7S. So write the remaining. Okay, so this is the way to write the electronic configuration. Okay children, so here that is study the symbol is that is important. So study 14 elements thoroughly. Okay children. So next topic, we are going to see the topic as oxidation state. It means here it exhibit from +2 to that is the +7. Okay, so +2 it is possible, +3, +4, +5, +6 and +7. Here that is the one word question they are frequently asking for this actinoide topic, that is common oxidation state and maximum oxidation state. Okay, so this two question, that is the repeated one. So the common oxidation state, that is +3. Okay, so maximum oxidation state, that is +7. Now we are going to see. Students, see the board. So now that is we are going to see the topic oxidation state. Okay, so in alkali metal it exhibits that is one oxidation state. For example, lithium, that is Li plus. Okay, so same way for alkaline earth metal, that is the +2 oxidation state. In that is the F block elements as well as the transition element, the single element it exists more than one. Okay, even that is one important property for transition elements, transition D block. Okay, so it exists more than one oxidation state. It behaves as a catalytic properties. Okay, we know very well. So here also in actinoide series, that is the 14 elements, it exhibit that is the different, that is the oxidation state. So +3, +3, +3 for everyone. So we say that is the common oxidation state for actinoids, that is the +3. Okay, so among this the highest one is that is the +7. Okay, so the maximum oxidation state is +7. Okay children, so here that is the +2 for thorium as well as that is the berkelium, that is americium. Okay, so +7 oxidation state, that is 3 neptunium, plutonium and americium. Okay, so this is the backside question children. So what are the element it exhibit as the +7 oxidation state? So we must, that is the concentrate for this area. Okay, this one how to that is study easy way means very simple. First write +3 +3. Okay, so next to concentrate berkelium, that is +4. Okay, up to berkelium. So next one americium, this is the that is the target, +5 to that is +5 +6 +7 +2. Okay, americium. Okay, so +5 starting to this. Next to leave this, so here that is uranium 2, that is americium. So next neptunium 2, that is americium. So +2 oxidation state for thorium as well as that is americium. Okay, so keep in your mind, so study this tabular column because the backside concentrate the question from this area. Okay, so we expect in annual also. Okay children, so next that is it is similar to this lanthanoid topic. So lanthanoid topic, that is we saw the lanthanoid contraction. Okay, so next that is causes of lanthanoid contraction. Same way for here also it occurs the actinoid contraction. That means the size that is the decreases from thorium to that is the lawrencium. Okay, so next to this contraction that is occurs due to that is the 5F, that is poor shielding. Okay, that is a imperfect shielding of 5F electron. Okay, so this is the reason already that is explained the previous video for lanthanide contraction causes. Okay, so just give the points only here. So here also that occurs the actinoid contraction. So what are the causes of this actinoid contraction mean? That is the poor imperfect, that is the shielding of. Okay, so that is the 5F electron. Okay children, so next we are going to see the topic distinguish between lanthanoids and actinoids. Children, now see the distinguish between lanthanoids and actinoids. Okay, so now I give the points. So just that is read the point and explain. In lanthanide, that is the differentiating, that is the electron enter in, that is the 4F orbital. Okay, so already told this is 4F orbital, that is lanthanide. The electron enter in, that is the 5F orbital, that is actinoids. So next the binding energy of 4f electron, that is higher. Here the binding energy of 5f orbital, that is lower. Okay. So next one, that is complex. So complex means that is the coordination complex. So less tendency to form complex. Here greater tendency to form complex. Here that is most of the lanthanide elements are colorless. Okay. So here that is some elements are colored. Uranium 3 plus oxidation state, it is red in color. Uranium 4 plus green in color, and UO2 2 plus, that is yellow in color. Okay, so this is the one word question, children. So study the color. Okay, U3 plus red, U4 plus green, UO2 2 plus yellow. Next here, that is do not form oxocation, do not form cation, that is oxocation. But here to form the oxocation, that is UO2 2 plus, NbO2 2 plus, etc. So next one, talk about the oxidation state. Here plus 2 state, plus 3 state, and plus 4 state. 3 state, that is exhibit. Okay, so this plus 3 state, that is the common. Okay, so this plus 4 state is, that is the maximum oxidation state of lanthanide is plus 4. Okay, so here the common oxidation state for actinoide is plus 3. Okay, so maximum oxidation state is plus 7. This is a one word question area. So next this one, less basic, already studied, that is according to Bejon's rule. The previous video we saw that. So this is lanthanide, that is less basic, is a more basic character. So next, in lanthanides, promethium only, that is the radioactive elements. Remaining all the 13 elements are non-radioactive. Okay, so in actinoids, all the elements are radioactive elements. This is the distinguish between lanthanoids and the actinoid, children. So for this lesson, the theory part is over. Okay, so this is the last class. So next video, that is take the book back side, that is a book exercise, one word question, that is I am going to discuss, children. So this theory part is over. If any doubt, that is if you want, that is send in the comment section. Okay, children, so this lesson part is over. So next I am going to, that is explain the book backside one word as well as 2 more question I am going to discuss. So children, that is utilize the time properly and see this video. Okay, so study properly. Okay, I hope you understand the topic, and I hope you studied the chemistry, that is a chemistry, that is all the lesson, not only for this. So concentrate equally and study line by line. Thank you, children.